Good evening. Today we will discuss about optics. Optics is nothing but study of light, and light is something which gives us sensation of vision or sight. So with the help of light we can see different objects around us. If there is no light, we cannot see it, because if light falls on an object, the light reflects from it and we can see it. So that is how the light produces the sensation of vision. Now light basically, as we know, have both wave and particle nature. Now in this class we will discuss both of them, the wave nature and the particle nature. Now before going forward, we should know what actually light is. Now, like I said, light is an electromagnetic wave which produces the sensation of vision. Now, if we want to say an electromagnetic wave, which is nothing but a transverse wave. Electromagnetic waves are an example of transverse wave, like sound waves are an example of longitudinal waves. The light is an example of transverse waves and subdivision electromagnetic. Now this is named as electromagnetic because that wave consists of both electric waves and magnetic waves. Both electric waves and magnetic waves are perpendicular to each other, and they both are perpendicular to the propagation of the wave. Now everything is perpendicular to everything, mutually perpendicular, like this. Now if this is the propagation of the wave, this will be the magnetic wave and this will be the electric wave. All are perpendicular to each other, mutually perpendicular. Okay, now moving forward, we will discuss about some terms connected with light. The first one is the source. The source means from which we can get some amount of light. The source can be of two types: luminous and non-luminous. Luminous sources are the sources which has light of its own, means who can produce light by itself. And non-luminous sources are again sources which can get light from them, but they are not capable of producing light of their own. Best example is luminous, our sun; non-luminous, our moon. We get light from both sun and moon, but we get light from moon which reflects the light of the sun. Alright, so this has light of its own, this does not have light of its own, but both are sources. We get light from them. Next is medium. Medium is nothing but through which, the substance through which light travels or propagates. A medium are again divided into three types: transparent, translucent, and opaque. Transparent mediums are those type of mediums through which light can pass easily. Translucent mediums are those mediums through which light can pass partially, and opaque cannot pass. Best examples: transparent glass, air; translucent water or paper; and opaque water, chair, table, etc., through which light cannot pass. Next is ray. Ray is nothing but a single channel light, or technically we can define a ray. It is the path through which light travels in a homogeneous medium. Now we all know that light travels in a straight line, but this is half current. light may change its direction according to the density of the medium. If the medium density remains constant, or in other words, we say that the medium is homogeneous, then we can determine, or we will assume, or we can confirm that light, if it passes through a homogeneous medium, it will always travel in a straight line. But if the medium of the density of the medium changes, then light may not travel in a straight line. We will discuss that further in the refraction. Now, ray is the path, is the straight path through which a light travels. It is a single channel path. Now, beam is the collection of rays. Suppose a ray is like this, beam will be a collection of rays. Okay. Now, similarly, pencil is a narrow beam. If you narrow the beam, it will be a pencil. Alright. Now, pencil are again three types. Pencil, narrow beam, three types. Convergent, divergent, parallel. So convergent pencil is that where all the rays of the light in the pencil seem to converge or meet in a particular spot. Divergent, opposite, where all the rays seems to be coming away from the spot. Parallel, they do not do. Alright, so these are some basic terms in optics. So before we study optics, that is the study of light, we should know all these basic foundation concepts. Then we will diverge into the main chapters. Optics is divided again into two types. Ray optics, wave optics. In ray optics, we will discuss reflection, refraction, dispersion, etc. Wave optics, we will discuss the Huygens wave theory, superposition of waves, interference, and double slit experiment. Young's double slit experiment. So first, we start from reflection. Reflection. It is the process in which light traveling from one medium gets obstructed by a reflecting surface and goes back to the same medium, like this. Suppose this is a reflecting surface. Now if a ray of light strikes a medium and it goes back to the same medium. Okay. Now in this case, we will say this one as the incident ray and this one as the reflected ray. Okay. And the line on the reflecting surface perpendicular is called as the normal. This normal is always perpendicular to the reflecting surface. Alright. So this is the basic example of a reflecting ray. Now, rules of reflection, that angle of incidence will always be equal to angle of reflection. That is, suppose theta I is the angle of incidence and theta R is the angle of reflection, then theta I is always equal to theta R. And the rule 2 says the incident ray, the reflected ray and the normal lies in the same plane. Now most students get confused about this same plane. They think that all the incident ray, normal ray and the reflected ray are on the reflecting surface, on the reflecting plane. That is wrong. It is not that. The rule 2 same plane says that this incident ray, normal ray and reflected ray has a separate plane. Now suppose this one is the reflecting plane, this one is the incident, normal and the reflected ray. We are talking about this plane, not this plane. Alright. So incident ray, normal and the reflected ray lies in the same plane, this plane. Okay, not the reflecting plane. Now, if we are talking about reflection, we should talk about mirrors. Now, mirrors are again two types: plane mirrors, spherical mirrors. Now, plane mirrors, we all know. The mirrors which are used in day-to-day use, like seeing yourself. Now, plane mirrors, the image formed by a plane mirror is the main concept here. Now, a plane mirror will form an image which will be virtual. Okay. Now, what is a virtual image? Now, the opposite of virtual image is real image. There are, when you are talking about optics, when you are talking about objects, when you are talking about images, then we should know that if a mirror or a lens forms an image, then that image will either be virtual or real. Now, virtual images are those images which can be seen by naked eye. Okay, we can see the virtual image. We cannot see the real image. Okay, real images can only be seen if it is taken on a screen. If it is not taken on a screen, we cannot see. Virtual images, we can see it with the naked eye, and virtual images cannot be taken on a screen. Okay, that is the first property of the image formed by a plane mirror. And the second property is size of object is equal to size of image. Third property, distance of object is equal to distance of image. And the final property is it is laterally inverted. Okay. So what is inverted? Only inverted is the case so that the top side becomes the bottom side and the bottom side goes to the top side, inverted. And laterally inverted is something different. In this case, the top remains top, bottom remains bottom, but the left becomes right and the right becomes left. That is how we call it is a laterally inverted, not properly inverted. Then comes spherical mirrors. They are again of two types. concave, convex. Now before defining all this, we have to know some terms. Suppose we are taking an example of a concave mirror like this. This is the reflecting surface. Okay. Now when we are talking about a mirror, now right in the middle, this line is called as the principal axis. Alright. And if we draw a parallel line to the principal axis and it gets reflected from the mirror, it will always pass through the point known as the focus. Okay. Now the middle of the mirror is called as the pole. And the distance between F and P, or the focus and the pole, is called as the focal length. Alright, now twice the focal length will be your C, center of curvature. Curvature is nothing but how much curvy the mirror is. Alright. So if we complete this mirror, the right center is the center of the curvature. Alright. And here the rule is CP will be equal to, or the center of curvature will be equal to 2F. Twice the focal length, F. Alright. Now another thing is this one. Point to point. This one is called as the aperture. And the plane, perpendicular plane going through the focus is called as the focal plane. Alright. Now, since we are clear about the terms, yes, now we can define what is a convex mirror and what is a concave mirror. Now, concave mirror we can define as a mirror in which, if we look from the reflecting side, this side, reflecting side, then the pole is depressed, and the aperture is bulged. Color depot. And similarly, a convex mirror is defined as the mirror in which, if we see from the reflecting side, then the pole is bulged and the aperture is depressed. Right. Very simple layman definition. Then comes the mirror formula. One by F is equal to 1 by V, 1 by U, where F is equal to focal length, V, distance of the object, V is the distance of image and U is the distance of object. Now similarly, if you are trying to determine the magnification of a mirror is nothing but I by O. Size of image by size of object. More the size of the image means more the magnification. Then comes the relative positions. Now in the whole optics chapter, in the whole reflection chapter, this one is the most important one. Relative positions. Or in other words, where will the image will form at a particular distance of the object. If the object is situated at a particular position, where the image will form and what will be the properties of the image. Okay. Now if you understand all these cases, then optics will be 50% easier. Okay. Now we will first take a concave mirror. Case 1, when the object is at infinity. Now if the object is at infinity, we will assume that the ray coming from the object situated at infinity will be parallel to the principal axis. Okay. In this case, it will pass through the focus and it will form a point image. Okay. Now, in this case, the properties will be real image. Okay. All the images formed by the mirrors, by the spherical mirrors, are 90% real and others are virtual. So, in this case, the image will be real and it will be inverted. Not literally inverted, only inverted. Top, bottom, bottom, top. And the magnification will be less than 1 because the object is situated at a very high distance and the image is a point image. So the size of the image is actually very less than the size of the object. So magnification will be actually very, very less than 1. Okay. Now the second case here is when object is beyond C. C means the center of curvature. So here it is the F, twice the F, C, and object is here, beyond C. In this case, first, every ray diagram, if we are drawing, then there will be two rays. One will be parallel to the principal axis, and the second will be going through the focus. Okay. So in this case, if the object lies beyond C, then the image will form between C and F. So here the properties will be, again, the image is real, inverted, and diminished. Diminished in the sense shorter in size, छोटा. All right. Now, since the image is diminished, then the magnification will be less than 1. Next case, we will bring the object to C. First infinity, beyond C, C, between CF, F, and between F and P. So object at C. So here we saw that if the object is at C, the image also forms at C, but the properties are again real, inverted, in this case same size. So here the magnification is 1. Now the question will be like this. A concave mirror forms an image equal to the size of the object. Okay. Or let me rephrase it. A concave mirror forms a real image which is same size of the object. What is the position of the object? Here the answer will be at C. Because if the object is situated at C, that is the only situation in which it will form an image at C and at same size. In all other cases, if the object is beyond C or after C, it will not form an image which is equal to the size of the object. So this is one of the big questions. In this case also, a concave mirror forms an image which is with a magnification less than 1. What is the object position? It will be beyond C. So, the next case is object will move towards F, or case 4, object between C and F. In this case, the image will form beyond C. Right. Same properties, real and inverted. In this case, not same size, it is bigger size, enlarged. Magnification will obviously greater than 1. Alright. So again question is, a concave mirror forms an image bigger than the object. What will be the position of the object? It should be between C and F. Again, case 5. At F. Now in this case, it will be a little different. The image formed in this case we cannot see. But why we cannot see? Because the image will be formed at infinity. Alright. So again, the image will be real and inverted. Or in this case, it is highly enlarged or highly magnified. So magnification here is very, very greater than 1. Last case. Six. Object between F and P. This is a totally different case. Now, if you put an object between F and P, this one will produce image like this. Alright, now in this case, the image is not real, it is virtual. The simple thing to differentiate between a virtual image and a real image is that the rule is, if the image is real, it will always be inverted. Real, inverted, real, inverted. And if the image is virtual, like in the case of plane mirror, we are seeing a virtual image. So virtual image will always be erect. Virtual, erect. Means top, bottom. Virtual erect, real inverted. We cannot see a situation where we will get a real image and a erect image. Okay, that is wrong. If you see in a question that it says that a image is real and erect, then that is totally wrong. Okay. Virtual and erect and magnified. So here M is obviously greater than 1. Magnification is greater than 1. Now in this case we saw that there are two cases here where a concave mirror forms magnified image. Okay, like in this case it forms a magnified image, and the other case is when the object is at C and F. Okay. When the object is at C and F, it also produces a magnified image. Okay, the difference between these two cases are, in this case the image is virtual and in that case it is real. So if the question is asked, a concave mirror produces a magnified image, then there will be two answers. Alright, a concave mirror produces a magnified image, it will be two answers. First case is, it will be either between F and P or it will be between C and F. Now if the question is, a concave mirror produces a virtual magnified image, then it will be this answer. A concave mirror produces a real magnified image, then it will be this answer. Between C and F. This one is F and P. So in the question, if it is not given whether it is real or virtual, then it will be two cases. Either the object will be between F and P or between C and F. If the options are given both the cases, then the answer will be both of them. Okay. So the last case is convex mirror. Now in case of convex mirror, there is only one case. Wherever the object it may be, doesn't matter the position of the object, it will always produce a virtual and a diminished image. Right. Doesn't matter where the object is. Even if you strike the object further or backwards, it will still form a diminished and a virtual image. So here, virtual, obviously erect since it is virtual, diminished, shorter image, magnification less than 1. Now this is the reason why we use a convex mirror in our vehicles, rear view mirror. Okay, because it will have a large range and it will form the image virtual from which we can see. If it forms a real image, we cannot see. Alright. For us to see an image, the image should be virtual. Alright. Since it forms a virtual image, wherever the object it may be, alright, that is why this kind of mirror is used as a rear view mirror. Alright. Wherever the object will be, it will always form a virtual image. Now, since it forms a diminished image, we can see a large amount of object behind us. In older days, we used to use only plane mirrors. Alright. But the plane mirrors do not have a large range. So that is why the rear view mirrors got switched from plane mirrors to convex mirrors. So with this, reflection is finished.